Testing, 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 testing. Okay, so on my main screen, I'm going to have, document. Where is it? Maybe if I Google Mars. Here we go. So this is like basically all the work I've done so far in one document. And my goal is to now try and condense the important parts into a lit review. And I would like to, if I could get like, I don't know, 800-ish words by tomorrow, that'd be pretty dope. Russian 8, thank you so much for the follow, man. So, okay, I'm gonna keep this up here, and then I'm just gonna get working on. I'll try and type it below, and then I can just put it into overleaf later on. Are you doing work? Yeah, man. I have a project report due next week, and I'm basically just like trying to condense the work I've done so far into a report basically. But most of it is just literature review, as you can see here on the left. This is all like previous work done by, I don't know, scientific researchers, employees at NASA on the concept, and I see trying to whip it together in a sort of story. At the moment, it's just kind of all over the place. Like, I found this, I type about it, I talk about it. But I want to try and make it cohesive, so if someone's just kind of reading for the first time, they can get an idea of what it's all about. A literature review, basically. Okay, so what am I up to? You're doing optics? Like in college? Like, what I'm trying to do right now is like just a review of what I've done so far. Grade 10 optics. What's that about? It's not too hard. I haven't done anything specific yet. I've just been reading and typing. That's all. Like, you know, in the papers they tend to kind of really talk about the most important parts, so it just kind of sticks out and you're able to type it down. So yeah, like this first paper here, for example, like they just talk about this all the time through it, so it's just gonna take that stuff and talk about it then, you know. I've never heard of optics in grade 10. Grade 10 is like, what, 14? Because I'm from Ireland and we have a different system here, so I'm not 100% sure. If I go down 14 to 15, okay. Like when I was 14 or 15 in school, we'd have loads of different subjects. You know, like I was doing like maths, science, languages and stuff, you know. I don't think I optics and physics, I guess. Like different types of lenses and stuff. I always found that stuff pretty difficult. I enjoyed it, but I thought it was very tough. I found it hard to visualize. Okay, so let's look. Okay, this is the list of all the papers, and I said yesterday I wanted to start off with methane. So what I'm going to do is I'm going to try and build a story. Okay, so to first build the story, I need to talk about what the problem is, and that is this section here. It's just 2 papers, so I reckon it's going to be in one of these sections. So we have discovery of olivine in Lily Fosse region, and we have extensive linear ridge networks. This is just talking about the region that we're investigating, like talking a little bit about the methane there. So let's check it out. Okay, so goals. I want to build a story. Start with the problem. Methane detection is bad is badly done by satellites and rovers. Then I'm going to introduce the concept of in situ sensing via, like, I guess, aircraft. In situ just means that you're there. Your remote sensing is you're sensing from far away. Yeah, see you, man. Thanks for hanging out. So, in situ sensing via aircraft. Yeah, you too, man. If you're doing optics with the physics stuff, like, yeah, with a concave convex lens, it's all it is, man. As far as I remember, anyway. But yeah, enjoy yourself. Have a good day, man. Okay. Introduce the concept of in situ sensing via aircraft. Okay. Explore types of aircraft. And then settle on super pressure balloon. Settle on super pressure balloon and explain why it would be the best option. Okay, so start with methane. Lily Fosse, detection, etc. Content of music is small, but where is my document? OneNote? Anyway, okay. Right. So let's not get too caught up with how to exactly word this. I just want to get the content down and we can try and make it look nicer then. I think it'd be interesting to base it off the abstract as well of the project. So let me get that. Okay. So I want to talk about the difference between satellites and rovers first. So current Martian observation entails or includes the use of both rover satellite, and as of the Perseverance landing. Helicopter. Do not provide comprehensive coverage of the landscape is the wrong words to use here. Because it's not just a landscape I'm looking to check out. The interest in flight missions to explore Mars arises due to the realization that rovers and satellites working in tandem do not provide comprehensive coverage of the of the environment, of both the landscape and atmosphere of Mars. Okay. Basically just saying that you have satellites which are up here, you have rovers which are down here. You're able to measure all of that pretty well, but there's a spot in between that they're not really fucking with. And that's the issue. Okay. So that's why. Oh, let me bring this down a bit. Okay, so that's why there's interest in flight missions. So let's get a bit more specific. What there is important to check out. Specifically in this dark, I don't know what to call it. Like it's a region of like it's no coverage, I guess. A dark spot, you could say. Specifically in this region where satellites and rovers have difficulty exploring. Is the No, I can word this better. Data from the lower atmosphere is not. I don't know how to fully say this. Let's check what the paper says. So this is the abstract for my project that I was given back in like September or something. The first few kilometers of the Martian atmosphere above the surface are particularly challenging to observe from Mars orbiting spacecraft due to enhanced extinction. Enhanced extinction just means the further you are away from something, you're not going to be able to pick up as much detail as if you were closer. So, for example, there's enhanced extinction between the sun and Earth in the heat that comes from the rays. The further you're away from it, the colder the rays will be. Similar thing here. If you're measuring something on the surface of Mars from a satellite, it's not going to be able to pick it up as easy as something right there like a rover would. So that's what enhanced extinction means. The arrival of ESA's Trace Gas Orbiter and subsequent science mission is a prime example, with dedicated search for methane yielding only an upper limit of 0.05 parts per billion above 5 kilometers. In contrast, on the surface, NASA's Curiosity rover, so this is like some instrument on the rover, has made multiple measurements of methane, including measuring an elevated methane background of this much, so it's much more. You have 0.05 part per billion here, and you have about 7 part per billion here. So yeah, it's going up by about 14 times. Or no, wow, 0.05. So that's like almost 200 times. Over a 60 sol period, I think, yeah, 1 sol is just 1 day basically. The discrepancy between surface measurements by Curiosity and orbital measurements from the TGO significantly constrains the mechanisms to corroborate the measurements and highlights the need for a detailed global exploration of the lower Martian atmosphere. So yeah, essentially saying what I'm trying to say here, but I want to say it in a different way. So satellites let's say this. Instruments on satellites provide results with decreased reliability the closer to the surface you get. And then on the other hand, similarly, instruments on rovers also provide results with decreased reliability the further from the surface, well, the higher in altitude you get. This discrepancy can be seen quite well when you compare measurements on the Curiosity rover. When you compare measurements made by the Curiosity rover with that of measurements made by ESA's, or by the European Space Agency's ESA trace gas orbiter. Is that called TGO? I don't know for sure actually. So I'm trying to just condense this paragraph into my own words, I guess. The TGO yielded an upper limit of CH4 of 0.05 part per billion volume at an altitude over 5 kilometers. Reference is in abstract. However, the sample analysis at Mars tunable laser spectrometer that's SAM, and that's TS. So I'm just going to put in square brackets anything that I need to change in latex. So plus minus, there's a symbol for that. I can use in latex. So if I just do it in square brackets and like caps it, when I'm reading it again, I'll be able to see it quite clearly. So that's plus minus 2.1 part per billion volume. CH4 over a 60 sol period. In 2013. And then again, reference is in abstract. out so far?
Matter of interest, I would like to see how many words that is. I imagine probably about 100. Word counter. Oh shit. 267 words. And we haven't even started yet. Like, that's just the introduction to the... Excuse me. Yeah, I'm actually not going to be able to go too deep in the lit review, so because realistically I'm going to have like my whole lit review is going to be less than 4 times what I have written down so far. I could get the lit review done today, holy shit. So yeah, what I might do is okay. Okay, I'm gonna like briefly explain why nitty phosphate was chosen. I'm gonna briefly explain why methane is an interesting thing to look at, which I've already kind of done here, right? I've said that this is one discrepancy of measurement between rovers and satellites, so that in itself is a reason why to explore methane. But it doesn't. I haven't given any information about what methane actually kind of hints at, or what evidence of methane actually leads to, you know. So I want to cover those 2 things. I want to go through maybe like 1 paper on a solar balloon, 1 paper on a sail, 1 paper on a wing, 1 paper on a drone if I can, and then like 2 or 3 papers on the super pressure balloons, saying like what the problem with them is, where the biggest kind of room for innovation is as well. And I think that's really good work then, to be honest. Yeah, I'm just gonna go make a cup of tea very quick. So let's go back to here and then go down to proposed plan, just so you guys can see us. Okay, so
watch something. Oh, who's this guy? I watched this already.
Many perseverance things. Me SN11.
Welcome to Great SpaceX. Wish you a very happy day. Are very happy to be healthy enough to bring you better quality videos every day and welcome your feedback so that the next video is better than the previous one. Our newsletter today has the following main content. 1. Elon Musk, SN11 will not upgrade the landing legs. 2. Elon points out the cause of the SN10 explosion. 3. Update info about SN11 after goes to the launch pad. Please come to the details section.
How's this?
1. Elon Musk. Elon points out the cause of the SN10 explosion. The landing leg problem of the SN prototypes has been mentioned from SN8 and SN9. Most recently as SN10 after this prototype was exploded, many suspects partly due to the landing leg of the SN10 too weak, which does not have a hydraulic mechanism strong enough to reduce jet when landing. On the Twister today, professional photographer Austin Barnard posted some photos, showing SpaceX engineers examining the SN11's landing leg. In Austin Barnard's photo, the SN11 prototype's leg has no change in design. After this photo was uploaded to the Twister, Elon Musk, the owner of SpaceX, explained that, "Dear Austin Barnard, SN10 engine was low on thrust due, probably, to partial helium ingestion from the fuel header tank. Impact of 10M/S crushed legs and part of the skirt. Multiple fixes in work for SN11.
It's like all
In
automated.
Elon Musk's answer, we can clearly see that the main reason for the SN10 landing was not soft and exploded a few minutes later. Due to the engine fault when landing with weak thrust, most of the force when landing is concentrated on the legs, leading to the broken leg of the SN10. The skirt of the SN10 is also damaged. According to Elon Musk, all of those
I didn't realize it was landing leg failure. Like from the videos, I thought that one of the engines blew, and there was a bit of a bounce, but I didn't think that the bounce is what caused explosion in the first place. Is that what he's saying? I don't know.
bugs will be fixed in SN11. In the
Maybe is he just saying that they're going to use the same legs? Maybe I misheard it. But
words of Elon Musk, the SN10 landing error is not due to the design of the leg, so
Okay.
the SN11
Yeah.
will not have the new design landing leg and still maintain the same landing leg.
so yeah, it's not the leg. They're just going to try and figure out why it blew up in the first place and only work on that problem and then introduce the legs in it.
As the SN10 landing leg. Elon Musk himself is also a brilliant engineer. I believe he has tested the lower landing legs many times, and there is enough reason not to change the design of the SN11 landing leg. SpaceX SN11 test flight, not making the same mistakes as SN10. Elon Musk said in another tweet that it was his fault as to why the SN10 had helium on its fuel tank which mixed with CH4 or methane, causing a reaction that turned the chemicals back to liquid. Musk said that it was intended to add the methane, as it is a safety precaution to avoid what happened to the SN8's initial explosion. The company is still looking into the Starship's test program and developing the spacecraft for its eventual use towards the Red Planet, wishfully bringing the first humans to Mars aboard the stainless steel ship. Moreover, the test program is said to run its course of failing, as the trial and error is integral to the spacecraft's improvement.
2. More in-depth about the cause of the explosion of SN10.
Okay, here we go.
Elon Musk said that they would make up for SN10's errors and explosion during the stainless steel spacecraft's test flight in Boca Chica. Unlike its predecessor SN10, SN11 can land safely without bursting into a fireball. SN10 flew 6 miles into the clouds on its first high-altitude test flight, passing the altitude level in the process. SN10 sailed, flipped, and landed without crashing and burning, unlike the previous iterations SN8 and SN9. Zeus, SpaceX's four-legged yellow robodog, surveyed the crash scene. This Boston Dynamics dog sniffed out hydrocarbon spills, tested facilities, took mechanical measurements, and conducted investigations in locations where a human person could be too unsafe. SpaceX CEO Elon Musk acknowledged that the SN10's low-thrust engine ingested too much helium. The
What's the
chemical
engine?
blended with methane that's supposed to serve as a precautionary measure to prevent a repeat of the SN8's initial explosion. However, these factors made a reaction that converted the chemicals back to liquid. Hence, SN10 exploded on its launch pad. Musk mentioned that the team is working on many fixes to upgrade the next Starship and make it ready for its flight test in time.
3. Update info about SN11 after goes to the launch pad. The latest Starship incarnation, the SN11 prototype, rolled out to its test booth on Monday, March 8 at SpaceX's Motion Area near Boca Chica Village in South Texas before an upcoming launch. It is expected to launch soon on SpaceX's fourth high-altitude Starship aircraft. SpaceX placed SN11 on the launch mount in the Boca Chica launch plant. The SN11 Starship maintains the program's build, aim, and intent, which is to be a stainless steel spaceship that will soon lead humans to Mars neighboring Earth. Apart from thrusters and landing maneuver capability, the SN11 hasn't seen many changes. SpaceX has yet to announce what has changed. According to Teslarati, SpaceX hopes to complete all certification tests by the end of the week. 3 Raptor engines have already been mounted on the SN11. Was pulled out to the launch site and placed on top of its test stand with a huge crane. The rocket is about 50 meters high and is powered by 3 of SpaceX's Raptor rocket engines. Starship SN11 is the latest in a family of large rocket prototypes built by SpaceX to test systems required for its massive Starship and Super Heavy rockets, the core of a new fully reusable launch system that the company hopes to use for trips to the Moon, Mars and beyond. On March 3, SpaceX launched its Starship SN10 vehicle at an altitude of 10 kilometers and managed to land the vehicle, although the rocket exploded shortly after being touched. This mission followed 2 previous flights of Starships SN9 and SN8, respectively, which also managed to take off at target altitude but failed to hold the landing. Both SN8 and SN9 exploded in massive fireballs during the landing attempt. SpaceX has made step-by-step adjustments and upgrades to the Starship design after each test flight, as it works to perfect the new launch system. The company has said that each Starship will be able to carry up to 110 tons, 100 tons, to a low Earth orbit. NASA has selected SpaceX's Starship as one of 3 candidates to potentially land astronauts and hardware on the Moon under the agency's Artemis program. Japanese billionaire Yusaku Maezawa has already booked a flight around the Moon on SpaceX's Starship for
Fucking
himself
dear me.
and 8 other passengers. Last week,
What a joke.
Maezawa announced a public competition to win the 8 places for his Dear Moon mission. That is the full
What
newsletter
a
today.
joke.
We will continuously update
I don't know if this is like made by a person or if it's SpaceX or if it's a bot or what.
Hi guys, wish everyone a new day with lots of energy and health. If this is your first time coming to my channel, feel free to press the channel subscribe button and turn on the notification bell, so you don't miss any videos. I'm so excited, and you guys too. Let's take a apple juice while I update the following main news. Thanks so much. Today's main information is SpaceX finds cause of Falcon 9 engine abort. Let's view detailed information.
Daily. Yeah. Twice in a day. It's pretty cool.
It's pretty cool. I thought it was like a bot, or I thought it was made by SpaceX or something. I was really confused for a second. But yeah, it's pretty cool.
Okay, yeah, let's get back to.
So, like I was saying earlier, like for my first iteration, I just want to get the story down. And then afterwards I can try and make it look nicer. Like, what? There's one sentence I read here when I sat down again. Where is it? There is a clear discrepancy between instruments which are measuring the same thing but are located at different altitudes when trying to provide data on CH4 in the same location of the lower atmosphere. Like, what the fuck am I trying to say there? Honestly, I think I might have fallen off something and hit my head. I don't know. So I'm just gonna leave it as is. You get the gist. There's something in the air, something on the ground. They're trying to measure something in between them, and they're both returning different results. That's all that's happening. So I'm just trying to get it down, and then I can work on make it sound nicer afterwards. Okay, let's put on some more music. Okay. Um, Okay, let's get going. I made some good work so far. I think I've like 250 words done. I thought this would take 2 days. I think I should get it all done in 1 day, which would be so nice. I have so much stuff to do. It's just good to get a good bit of work done. Okay, so what have we done so far? We discussed that so far on Mars we have rovers, satellites, and helicopters. Helicopters as of very recently. And we talked about why we have helicopters. Like what Ingenuity is doing basically is testing for future helicopters and future control flight. So why are they interested in that? We answered that question, talking about the discrepancy in results. Now, I could probably make that a bit smaller. I essentially said in like 3 paragraphs what I could have said in like maybe 2 or 3 sentences. But it's fine. We can shorten it down later on. What matters is that we're hitting the points. If we throw too much mud at the wall, it's fine. We'll clean it up after. So here is a nice segue to talk about methane, and then to talk about specific areas in Mars that have increased kind of detection of methane. So moving forward, let's talk about methane. So why is there? What's the deal with methane? What's the deal with methane? Yeah, I didn't mean that. That's it. That's the deal with methane. Methane on Mars. Huh. So I'm going to briefly touch on serpentinization and also how it can be stored in like the rocks and stuff. Thank you.